Imagine yelling in a big empty hall. Your voice travels, it hits a wall, then it bounces back, you hear an echo. Radar does something very similar, but it uses invisible radio waves, not sound. It's a clever trick. The idea wasn't born overnight. Scientists noticed radio waves could reflect. This was way back in the late 1800s. Heinrich Hertz, who discovered radio waves, saw this. He probably didn't imagine guiding planes then, but he saw a spark, a hint of something new and profound. Science often starts with these small, curious clues. Then a big war came. World War II. Suddenly seeing enemy planes was vital, especially crucial at night or in dense fog. This urgent need pushed radar development forward, hard. Scientists in Britain and other places raced against time. They built machines that could find distant planes. These innovative machines sent out radio pulses, and then they listened intently for the faint echoes. These early radar systems were absolute game changers. They provided an invaluable early warning. They helped defend cities from aerial attacks and ships from unseen threats. It was like humanity gained a powerful new sense, a remarkable way to see far beyond human sight. The previously invisible became suddenly visible. This groundbreaking technology fundamentally changed warfare, and soon it would change so much more in our world. So how does this seemingly magic box actually work? First, you need a core component, the transmitter. This part is responsible for creating the radio waves. Think of it much like a special, powerful flashlight, but instead of visible light, it shoots out radio energy. These waves are a specific type of electromagnetic radiation, just like the light we see, or medical X-rays, but with much longer wavelengths, making them invisible to us. Next, there's an indispensable part, the antenna. The antenna is critically important for the system. It sends the generated radio waves out into the world. It often focuses them carefully into a directed beam, much like the reflector in that conceptual flashlight. The very same antenna, or sometimes a different one nearby, also listens. It patiently waits for any returning reflected waves, a truly dual-purpose tool, which is quite neat. When these specially generated radio waves travel, they keep going. They propagate outwards until they hit something solid. This something could be a massive airplane, or it could be a ship on the ocean, or even tiny raindrops. When the radio waves strike an object, they bounce off. They scatter in many different directions from the surface. Some of these scattered waves will inevitably travel back towards the waiting radar's sensitive antenna. The antenna then catches these faint returning waves. It quickly sends them to another key part, the receiver. The receiver is designed to be super sensitive. It amplifies the incredibly weak echoes it detects. Then, sophisticated electronics process these signals. It figures out precisely how far away the object is. This is based on the round-trip travel time of the wave. Finally, this vital information appears clearly on a display, often as a familiar bright blip on a dark screen. Think about the experience of flying in an airplane. There are often many planes in the sky. How do they all manage to avoid each other? Radar is a huge, indispensable part of the answer. Air traffic controllers constantly use powerful radar systems. They see all the planes as moving dots on their screens. They use this information to guide pilots safely. Radar also helps planes land correctly in very bad weather. Ever check the daily weather forecast on your phone? Do you wonder how they know rain is coming soon? Radar technology helps significantly with that too, you know. Specialized weather radar sends out its radio waves. These particular waves bounce off raindrops in the clouds, and they also reflect off snowflakes or even hailstones. The weather radar system sees all these reflections. It shows us where storms are and which way they're going. Ships navigating the vastness of the sea also rely on radar. This is especially true in the thick fog or during the dark night. The ocean is incredibly vast and can be quite dangerous. Radar helps ships to see other vessels nearby. It helps them accurately spot distant coastlines and critically avoid hitting unseen rocks or massive icebergs. It's a truly crucial tool for safe maritime navigation, keeping sailors, passengers, and valuable cargo secure on their journeys. Radar isn't just for these big, impressive things. Police officers often use handheld radar guns. These devices check how fast cars are actually going. The gun sends out a quick radio wave pulse. It bounces directly off your approaching or receding car. The subtle change in the wave's frequency tells the speed. Some very modern cars also use radar technology now for features like adaptive cruise control or automatic emergency braking systems. Radar has truly, profoundly changed our modern world. It made previously invisible threats suddenly visible to us. It made all forms of travel significantly safer. It helped us understand our planet's complex weather patterns. It effectively extended our natural senses far beyond their normal limits, from critical military defense applications to everyday conveniences. Radar's wide-ranging impact is all around us, every single day. Even if we don't always consciously see the radar itself working, this remarkable technology didn't just stop evolving, it got progressively smaller, impressively faster, and much smarter. Radar is now found inside self-driving cars. It helps these autonomous vehicles to see their surroundings. It's also used in unmanned drones for precise navigation. Scientists utilize it to study Earth's dynamic surface, even to map the hidden terrains of other planets. The fundamental principles remain, but the applications continually expand. So, what does the exciting future hold for radar technology? Scientists and engineers are working on many new ideas. Imagine advanced radar systems that can see even finer details, or perhaps radar that uses significantly less power to operate. Maybe even radar that can identify different types of materials, not just detect an object's presence and location. Artificial intelligence will likely make radar even more powerful, helping to interpret vast amounts of complex data very quickly. Radar began as a clever way to detect simple echoes, a surprisingly simple concept when you really think about it. But it unlocked an entirely new way of perceiving the universe. From the expansive skies high above us to the roads we travel daily, and even venturing out to distant, mysterious worlds, it's a magnificent testament to enduring human ingenuity. Taking a basic principle from physics, a simple observation, and skillfully turning it into a technology that continues to shape our future, still unveiling the invisible for all of us every single day.